Hey everyone, this is Bathymetrics. This video is going to be a deep dive into the subject of oversampled clippers. Should you oversample them? Should you not oversample them? Especially in the context of my mixing loud with clip to zero strategy. To get your attention and help you understand it might be worth sitting through this video, I'm going to show you some points I'm going to cover here. I'm going to make some broad assertions. These assertions are going to fly in the face of some theoretical truths we know about audio. I'm not alone in making these assertions, and I'll prove that. So let's just go right down the list real quickly to help you understand what I'm going to talk about in this video. There are two different ways to use clippers. One is for audible colored distortion or saturation. A lot of distortion types that we're used to, especially what we broadly call saturation, is really produced in the digital world by a clipper of some sort, even if they sell it as a saturation plugin. What it's doing under the covers is a certain type of wave shaping that we typically call clipping. And if it's a soft clipping curve with a little bit of a knee before the actual flat line at the top of the clip, that's called soft clipping, and that is the sound of saturation. And the different nuances of saturation just depends on the shape of that knee, right? And how hard you're driving into that knee. And there are a lot of very subtle differences you can get out of slightly shaping that knee in different ways. This is all nonlinear wave shaping. Now, there's a whole nother way to use clippers. This is what I primarily talk about in the clip to zero strategy, and that is to use clippers for transparent control of your dynamic range. Like a limiter, as I've said in the past, a clipper is like a super lightweight, kind of dirty sounding limiter, okay? But it's still mostly transparent, even though it's got a little bit of dirt hiding in the minute instance where the clipping actually occurs. And that dirt can actually be pleasant in some ways on certain types of sounds, like, for example, drum sounds, okay? It can actually, while you're reducing the transients and maybe softening up the snap of a kick or a snare, the dirt, the little dirty spit that's added by the clipper actually kind of puts back some of that perceived transient punch. And so you're both controlling your dynamic range and keeping a sense, or even sometimes enhancing the sense of that dynamic punch in a very loud, dense, busy mix. Okay, so I'm also going to make a broad general recommendation that you should typically use oversampling where it's practical to do so when your goal is the audible colored distortion and saturation, okay? Coloring with saturation, hearing the distortion of the saturation, right? Generally speaking, in most cases, if you can use oversampled processes to do that, you should, because it will be better in the long run, especially when you're using lots of distortion and saturation across your entire project. And this is true whether you're going to do this with a clipper or some other type of wave shaping plugin. It could be a distortion effect. It could be kind of a creative distortion tool like thermal or rift or isotope trash, right? Any kind of a zillion creative distortion tools. The distortion effects in things like Serum or Vital or any kind of synth, right? Any kind of wave shaping that causes distortion where possible. Yeah, you should use oversampling. There's good reasons to do that. And again, I will kind of demonstrate this in this video. Where I'm going to get some pushback, and some people are going to have been disagreeing and will continue to disagree. This is one of those debates in audio, like loudness versus dynamics. You can't win this debate. There's different camps. People get very passionate about this. But I'm going to assert, as my opinion and my advice, that you should not typically use oversampling when your goal is this usage of a clipper for transparent dynamic range control. And the reason I make that assertion, and I'm going to demonstrate that in just a moment, is that when you're doing transparent control of dynamic range and you have to shave the clips right to an exact spot, the good clippers that are good for this process have a sealing control on them, and that sealing stage pretty much undoes most of the benefits of oversampling the first stage. And more importantly, because a clipper is kind of like a limiter in the way that it works and its total effect, I can point you to people who will say they do not like the sound of oversampling on a limiter for a lot of material, a lot of projects they work on. You know, sometimes the oversampling, although it is theoretically better, in practice, it doesn't sound better. And so, yeah, that's a point I'm going to make in a second. And then finally, I'm going to make the point that in this context of transparent dynamic range control, all of those clipping events are incredibly short and kind of spread apart in time. And so any aliasing that happens for that instantaneous, like few milliseconds or 10 milliseconds of the actual clip itself, that aliasing is so subtle and indistinguishable, you can't even really hear it necessarily. And if you do hear it, again, it might actually sound better than if you were to try to reduce that aliasing with oversampling. And yeah, we'll get into that. And then finally, I'm going to talk a little bit about why I still recommend KClip as this is the clipper I think you should use for my clip to zero workflow. And it has to do with the fact that other clippers, you know, they all sound good. Even though they're fine in terms of what they do to the sound, they can be harder to work with in the kind of workflow I teach you in the clip to zero method. And other clippers' claim to fame it often revolves around their oversampling features and the fine control they give you over the way they do their oversampling. And that's great when your context is audible color distortion or saturation. It's not so great when your context is transparent dynamic range control, because some of those oversampling features can make the clipper a little complex and confusing. And especially if you're new and struggling with all this, I kind of point you at KClip, because KClip is a lot harder to mess up with when you're using it for dynamic range control, whereas other clippers have a lot more options for you to consider, and it can distract you from the options you should use. And then finally, I'm gonna demonstrate how the oversampling plus the kind of hard sealing you have to have for this second use case of dynamic range control, oversampling plus the sealing in KClip actually will reduce the aliasing slightly more than the other big clipper out there that people really like, which is called standard clip. So I'm going to demonstrate that. And I think I'm going to start out by saying some of you may be really familiar with what oversampling is, what aliasing is, or aliasing foldback, what aliasing artifacts, aliasing distortion, intermodulation distortion, anti-aliasing filters, and how they remove aliasing from an oversampled process. You may understand all this theoretically, but some of you might not. So rather than me trying to give you a crash course in all this, I'm going to put a link in the description to a great video put out by FabFilter, but it's actually done by Dan Worrell. And it's called Sample Rates, the Higher the Better. And I cannot recommend highly enough. If you've never seen this video, please go watch it, because it's brilliant. And it's not just about the sample rate of your project. Should you use 44.1 kilohertz? Should you use 48 kilohertz? Should you use 96 kilohertz, right? There's like a little argument out there about which sample rate is best to produce at, right? Or to mix at. Spoiler, 44.1 is fine for a lot of us. If you can run a project at 48 kilohertz sample rate, it might be better, but your mileage may vary. It's certainly a little bit heavier usage of your CPU, and so you'll find yourself flattening tracks more often, running out of headroom on your audio buffer on your audio interface a little sooner than you would at 44.1. And the payoff is a little bit minimal, but there is no question that overall, if you can run your sample rate at 48 when you work in production, you probably should. I do. I don't in these YouTube videos because YouTube's 44.1 and I feel like the sound maybe translates a little better when things are transcoded for YouTube. But when I'm working on my own projects, yeah, I work at 4800 now, or 48K now. And this video will explain why really well. It's going to teach you all about sample rates. It's also going to teach you all about how oversampling works and how anti-aliasing works and what aliasing looks like and sounds like. And Dan's got great A/B comparisons of things at different project sample rates and different oversampling amounts. And it's just wonderful. It's worth every moment of the 30 minutes you're going to invest in this video. I go back and watch this thing all the time just to really burn these concepts into my own head. So please go look at this if some of the terms I throw around go over your head, or if I seem to be moving too fast and you're not quite grasping what I'm trying to show you or why I'm making some assertions. But let's start with KClip versus, for example, standard clip. Because I put out a video yesterday, the night before, I did a follow-up to a quick and dirty video I made a couple days ago about KClip 3.5. There was a new version of KClip that came out. The creator, Shane Kazrog, completely rewrote it, rebuilt it from the ground up, gave it a new GUI. And some of my early viewers said, hey, we feel like, you keep recommending KClip. I feel like the new version has some problems and maybe is using more system resources. And I went to check myself, did my own testing to see whether or not it really was taking more system resources than before. And you can go watch this video. It's only 10 minutes long. It's a little quick and dirty, not edited. I screwed up at the end because I was constantly pausing and unpausing OBS to set up big 50-track test projects in different ways to do this testing and take measurements. So the end of the video got cut off, and I'll just briefly, for the people that have wondered what the ending of this video was like and should have been like, at the end of it all, my measurements showed that the new version of KClip 3.5 is just as resource light as the previous version 3.2.4 if you turn the visualizer off. That's the money shot for the video. If you turn the visualizer off, it's exactly the same as before. It's the same plugin, just with a different GUI, and of course, more efficient under the covers. Now, the new visualizer does seem to take slightly more resources than before, but emphasis on the slightly. It's a minuscule difference, right? So if you like the new visualizer, turn it on, don't worry about it. KClip is still just as lightweight as before. You can have tons of them all over your project. I show 50 instances of it running all at the same time, like on 50 different tracks. And, even with a small buffer size of 256, it's barely taking any resources, compared to all the other big, heavy things you typically have in a project. So this video raised some questions about oversampling. In the comment thread, people were asking about oversampling. And the creator of KClip made some comments saying, hey, I really like the CTZ method, but my recommendation is whenever you're going to render audio, like bounce a track and flatten it to audio, or if you're going to, print your final masters, you should always turn on oversampling inside of KClip. And, okay, my impression is that's not always true as a blanket statement, and I'm going to make a case for that in this video. Although in some ways, theoretically, it is true for the reasons I talk about and we'll kind of, elaborate on a little bit for colored saturation and distortion. It's kind of like this is a case where theoretical truths sometimes rub up against practical outcomes. And sometimes the way we actually practice flies in the face of theoretical truth. And so I hope to make this a little bit clearer in this video. So I tried to put out a video about oversampling a couple days ago, and I screwed up. I definitely screwed up because I have had standard clip forever, but I don't use it, and I haven't used it. I haven't touched it in a year or two for a couple reasons I'm about to summarize for you. And I honestly forgot how part of it worked. And I made a misrepresentation about this plugin. And it was bad because it made it seem like standard clip was a piece of crap, and it's not. And I apologize for that. About 400 of you saw that version of the video before a couple people alerted me to that gaffe. And I said, oh crap. And I yanked the video. So in this video, I hope not to make a similar mistake. And I'm just going to put out a reminder here. I mean, I say some things that are controversial in my videos. I know that. And if you ever want to argue with me in comments and offer up your counterpoints to some opinions or assertions or recommendations I make, I'm totally okay with that. I like people to hear counterpoints to what I say. And I also am the first person to admit that I can sometimes make my own cognitive mistakes, my own logical mistakes. I may get things wrong. I may demonstrate things wrong. I may goof up. By all means, point those out if you think you see them. Just do it in an objective way. If you're nasty, I'm going to moderate that out because I don't want toxicity on my video comment threads. But if you're objective and cool about it, by all means. And other people can, read any kind of discussion that might come from that and make up their own minds. And certainly if you ever see me make an outright mistake, if you think I've made an outright mistake, correct me. And for example, Shane, if you're watching this video, Shane at Kazrog, and you disagree with anything I'm about to say in this video about whether or not to use oversampling in certain contexts, I'd love to see your opinion in a comment. So go for it. Okay, so let's get right down to, I'm kind of going to work backward and just explain why KClip is still my recommended clipper for the clip to zero workflow. It boils down to something I say in my videos about episodes 5 and 6 of my clip to zero method, where I really lay this out in detail, step by step. I talk about controlling the dynamic range of sounds by first saturating from the bottom. I call it saturating from the bottom. And then after that, clipping from the top. And I'm not going to belabor this. Go watch these videos if that's not ringing any bells with you. The basic idea is when you use any kind of saturation or distortion on a sound, chances are really good that in most cases, you're increasing the RMS or LUFS, the perceived loudness of the middle part of the sound, more than you are increasing the peaks. And so in the long run, saturation and distortion of any type, any kind of wave shaping for tonal coloration, to make it sound a little hotter, or to sound a little dirty, or whatever your goals are in sound design. Applying any kind of wave shaping, saturation, clipping for that colored use tends to increase RMS more than it also increases the peaks. And so it reduces the total crest factor of the signal, and that's a good thing when you're trying to work in genres where you have to ultimately cram your mix into a very small dynamic range and push it right up against the ceiling at 0 dB full scale or -3, 0.3 full scale, and get a very loud result, right? If you work in louder genres, that's a good thing to use saturation because it helps you make a track perceptibly louder and then push it higher in your mix without overshooting 0. So we always saturate from the bottom first because we're going to get a little bit of crest factor reduction most of the time out of that. But usually saturating alone isn't enough, and so you still might need to push down the peaks from the top. And there are a variety of ways to do that. Of course, a limiter is one way to do that, but a limiter works by cutting new release envelopes into your signal, which changes the dynamic feel of the signal. And in some ways, it can be more transparent not to use a limiter, but to instead use a hard clipper, specifically a hard clipping shape, not even a soft clipping shape, because soft clipping will start coloring your sound and affecting parts of the waveform that are below the threshold that you're clipping at. So often the most transparent way to just shave some taller peaks and therefore reduce the crest factor of a signal you've already saturated as far as you want to for coloration, the most effective way is often with some clipping from the top. If you do it right, it's very transparent and you won't really hear it unless you know exactly what to listen for and you have a very trained ear. Your listeners certainly won't hear it. And in that context, I feel like the easiest workflow that I teach is done with KClip compared to every other clipper I've seen out there. And it really revolves around the fact that in KClip, you can link your input and output knobs, and you can test for where the clipping point is that you start hearing the clipping and it's no longer transparent. Or maybe you're finding that threshold where you're starting to hear the clipping, but the clipping itself actually sounds good, because it can, especially on really percussive or highly transient material, or very bright material. Sometimes just a slight edge of hearing the clipping actually makes the material feel punchier and actually stand out in the mix more where you might want it to, a busy, dense mix. It's doing that at the same time. It's also very surgically shaving those peaks right down to the level you need them so that you can raise the balance of that particular sound louder in your mix to sit where it needs to in a loud, dense mix in a small dynamic range. So being able to sweep back and forth with a linked input-output knob keeps the perceived loudness almost identical as you're testing for that point where the clipping is audible, and then the point where the clipping is too much, and then the point where the clipping isn't audible at all, and just finding that sweet spot where you're making that best trade-off for transparency. And then once you find that point, hearing it apples to apples at equal loudness because of this linked behavior, I say, find that clipping threshold at equal loudness, and then double check it by bypassing the clip-in on and off. Listen to the unclipped signal, and then listen to it clipped, and listen to it unclipped, and listen to it clipped. And you're doing it inside the plugin, so there's no latency or lag, and it's all equal loudness. And so you can double check really clearly that, yes, the amount I've chosen to clip this sound is either fully transparent, and I can't hear it at all, or if I am hearing the clipping, I believe it sounds good subjectively. It's actually an improvement, or at least it works in this mix. And I don't mind that part of what I'm hearing replacing the original transients is the sound of a kind of intermodulation distortion that we call aliasing. The aliasing in some cases actually sounds good on certain kinds of signals. And I'll make that point again in a minute about limiters. So then when you find this spot and you've A/B tested on and off, that's when you unlink it, double click this, and you're good to go and can move on to the next track. It's very fast and easy to set a good transparent amount of clipping this way with this plugin. It's one of the things I love about KClip. And so this is the main reason I use KClip, but there's another reason that has to do with oversampling I'll show you in just a minute. Now, by contrast, there are other popular clippers out there, and I would say the most beloved clipper by many is Standard Clip. Now, Standard Clip is a very, very good clipper. It provides a whole lot of control over some details about your oversampling, including being able to adjust the slope of the filter regardless of your project sample rate. and other things. You can decide whether you want to use a linear phase filter or a minimal phase filter because they have two different sounds and they'll have different effects on your project. It's a very capable clipper. It's a very configurable clipper. There's no question. It's a great clipper, especially if you're using it for sound design and you want to use oversampling to its full benefit in that sound design context. However, from the standpoint of using this for transparent dynamic range control, kind of using it like a limiter, like a dirty limiter, it's not so friendly. And this is the main reason I haven't used standard clip and I haven't recommended standard clip in most of my videos about clipping and clipping for dynamic range control. Because in standard clip, correct me if I'm wrong, but I have poured through the documentation backwards and forwards. I've clicked every key combination I can think of. There's no way to link the input gain to the output gain in a reverse way. To do this same kind of linked testing for the right amount of clipping that's transparent, you can't do this in standard clip. You can't, drag this control up and down and somehow have it affect the output gain in an inverse way so you can test for equal loudness any given amount of clipping. And to me, that's a big problem. Let me set this back where it was. The other problem with standard clip from a workflow standpoint is I've never found a way to bypass it inside of the plugin itself. I have to literally come over here and turn the plugin on and off, which tends to could cause a pop from latency. And if you're using, especially if you're using oversampling and you're using a linear phase filter, which is causing some amount of latency, right? You have this pop that kind of disrupts your ability to smoothly A/B compare what it sounds like with clipping and without clipping, because you have to turn off the whole plugin itself in your DAW. So those are two workflow reasons I prefer KClip, but I'm about to show you the second reason. When you're using a clipper for dynamic range control, one of your goals is to make sure you're actually truly clipping the peaks at whatever threshold you've set. So what you see here is a test tone at 200 Hertz. Here's the fundamental right here at 200 Hertz. And I'm pushing this sine wave right now through standard clip. So we'll show that first. I'm pushing it 5 dB above zero by driving the input. The ceiling is set, the threshold is set at 0. The gain is neutral at 0, and I have standard clip ceiling engaged. So that even with the oversampling, it's shaving it back down to the absolute 0 mark. And I'm going to talk about what the ceiling means on versus off in a minute. This is what I screwed up yesterday when I attempted to show this yesterday. KClip also has a ceiling knob that works the same way. The problem is when you're oversampling a signal and you're using the ceiling to prevent a certain problem from oversampling that I'll demonstrate in a minute. It's hard to demonstrate it on a sine wave, but I'll demonstrate it on something different. When you're using a ceiling value to keep your peaks truly under control at a certain point, the ceiling itself is actually some kind of secondary clipper. It's almost as if you've got two stages of clipping going on, and maybe it is under the covers. It certainly looks like two stages of clipping. And so your first stage might be applying oversampling and getting all the great benefits from oversampling, but as soon as you turn the ceiling on, you seem to lose most of those benefits. And the aliasing comes back. And I'm pretty sure that's because this ceiling, the only way you can actually create a true ceiling for a clipper is by using a second stage clipper that is not oversampled, and it's a hard clipper to get this final clip. So let me kind of show you that. If you look at this, this is the classic demonstration of what aliasing foldback looks like. I'm in a spectrum analyzer. I'm going way down towards the noise floor. Most spectrum analyzers will stop anywhere between 90 dB and maybe 60 dB. So you're usually only seeing what's above this line and everything looks hunky-dory. But there's actually any kind of nonlinear process is going to create this aliasing foldback from Nyquist. So your harmonics created by the clipping or any kind of nonlinear process, even compressors do this, even limiters do this to some degree. As you move down in this direction, they hit this invisible wall at Nyquist and bounce backward. It folds back in this direction, and that's causing harmonics that are no longer related to the fundamental because they got folded at a weird arbitrary point. And so these things that are reflected backward are now anharmonic. They're not related to the original fundamental, and it's a harmonically related set of overtones created by distortion. And so this whole foldback thing is called aliasing. It's considered an unpleasant type of distortion that could be described as brittle, ugly sounding, metallic, and even worse, especially if these sine waves are moving around. Like music isn't just a static sine wave. All these sine waves are constantly moving. And so harmonics created by distortion are kind of all moving in one direction, but the foldback is moving in the opposite direction. And so they rub against each other in a way that's similar to phasing. And as they rub against each other, it creates what we typically hear and describe as intermodulation. And that's a kind of ugly sound that isn't musical, okay? So when you're playing a pure constant sine tone, which is basically just a solid wall of pure RMS, there's no RMS versus peak here. There's no crest factor. It's a wall of constant RMS when we play a sine tone and take a look at it in a generator like this, in a spectrum analyzer. And so this is very hyped and overemphasized. I want you to understand that. What you're looking at is very artificial and doesn't really match what real musical signals look like when they're clipped in this way. So we're running 8 times oversampling, and yet we're seeing aliasing foldback. Why is that? Well, that's because of this ceiling button. If I turn the ceiling off, all that aliasing foldback disappears, drops way, way, way down to the very noise floor. And now this is just a pure, wonderful set of harmonics with no aliasing. None of that intermodulation distortion. Any intermodulation that's happening is so far down towards the noise floor, it's imperceptible completely. But as soon as I turn the ceiling on, hey, I'm seeing aliasing distortion at least down here, right? Now, this is still really far down, and it's really subtle, and I'm going to make this point. If you watch this Dan Worrell video, he makes a point at the end of the video. Look, aliasing is usually really hard to hear unless you're listening for it. So really, at the end of the day, don't stress about it too much. This is largely theoretical stuff. And this is what you're seeing here. This foldback and this intermodulation is so far down, you're probably not going to notice it even in this sine wave. Maybe a little bit. But again, this is very artificial and overhyped. So again, watch when I turn the ceiling off. Now we're seeing the pure 8 times oversampling and the wonderful benefit of oversampling. But the minute I turn the ceiling on to absolutely clip these things at 0, all that aliasing comes back, or most of it comes back. Now, the next thing I want to show you is why I believe KClip is better even on the front of aliasing distortion. So let me reset this to be the same as standard clip. Okay, so we're clipping the same amount, 5 dB, threshold's at 0, ceiling is at 0, ceiling is engaged, and it's a hard clipping shape, soften is at 0%. So when we flip over here to KClip, we're now looking at KClip, and it's oversampling plus the ceiling knob engaged. And we are seeing a little bit of aliasing foldback down here and some intermodulation happening. If I turn off the ceiling, just like in standard clip, you're going to see all that foldback go away. Just pure, clean harmonics marching off in this direction. nice, tasty sounding distortion on this sine wave, okay? Minute I engage the ceiling again to absolutely clip this at 0 no matter what, we get that aliasing fold back again. But notice that it looks different. See how flat it is and how low it is? It's down here, like these peaks are sitting at around a negative 112, 113 decibels on this meter. Now I'm going to flip back to standard clip just by clicking this button and see how they're slightly higher and it's slightly more dense looking here. And if I hover my mouse near the top of these peaks, it's more like negative 98 dB. Again, I'm going to go back and forth. Standard clip with 8 times oversampling and a ceiling versus KClip at 8 times oversampling plus a ceiling. See the difference? Now you can't hear the difference because that's all really far down in the noise floor, but you can certainly see the difference on a spectrum analyzer, right? So if you're worried about the theoretically bad, quote unquote, bad sound of aliasing distortion and intermodulation distortion, if you're worried about that, from a theoretical standpoint, its approach to doing a ceiling isn't quite as clean as the outcome you get from KClip and its approach to implementing a ceiling. So under the covers, I don't know what's different. They're both perfectly good and robust clippers if you've turned the ceiling off and you're just using pure oversampling. And then the big difference between the two is in mostly, we don't usually use hard clipping as a pleasant type of distortion. Usually we use some sort of soft clipping, and so, standard clip has a way to do its variable soft clipping curve, and they're all going to have different sounds. It's got a different, version of soft clipping that shapes that knee in different ways, depending on the algorithm you pick. Right here's kind of a 2-stage semi-hard knee, and all of these are going to sound different when your goal is sound design and coloration, and you want to hear the clipping of the wave. KClip has its own different approach. It's got a whole bunch of different soft algorithms based on, classic forms of analog clipping or hardware transformers or guitar amps or whatever, and then whatever algorithm you pick, you control the knee this way. And yeah, you can't see it in a graphical way that shows you the transfer shape or the wave shape, but it's there and you can certainly hear it. And they're just going to have different characteristics, and this is where the two clippers differ from each other, all right? Really, is where it comes to their sound design features. But even for my use case of dynamic range control that is as transparent as possible, if you're worried about the cleanest possible transparency, this is demonstrably less artifacting, lower, closer to the noise floor than standard clip with its ceiling on. That's demonstrably more aliasing higher up from the noise floor. Okay? And now we're going to just play a standard top loop through both of these clippers and talk a little bit about this from a dynamic range control standpoint. So what we've got here, you can see in SciScope, is a typical drum top loop. Of course, the spectrum analyzer is going crazy. The spectrum analyzer is not very useful to us now because look how dense all this information is, right? And whether I've got oversampling on or off or turn the ceiling on or off, we're not going to be able to see the aliasing foldback anymore because there's just too much information going on here. So we're going to turn this off so it's not distracting us. And we're just going to focus on these two plugins kind of side by side as I show you some changes to the waveform down here in SciScope. Okay. So I'm going to start by turning oversampling off in both of these. I can just do it all in standard clip because at this point, standard clip will show you what you need to see. So here's our waveform. I'm going to turn off all the clipping so you can see the original drum loop. So this is completely neutral. What's coming through standard clip is completely neutral. This is the original drum loop that we're seeing. This is a typical use case for dynamic range control. I have a drum loop. I want to fit it into my project. My project has a lot of other very loud framework sounds in it, and melodic sounds and harmonic sounds, and I'm working in a very small dynamic range. My goal is to work using the clip to zero concepts so that I want to hear the consequences of choosing certain sounds and making certain mixing decisions and making certain arrangement and sequencing decisions about my composition itself. I want to hear their final effect at a mastered final amount of loudness, because this is where traditional workflow, I think, fails people and really confuses new producers. I really shouldn't dive down this rabbit hole. Go watch my Clip to Zero series to understand what I'm getting at here. The point is, my use case is I need to make this drum loop louder because it's too quiet in my current mix, right? Now, the problem is this drum loop, this sample, coming straight out of a sample pack, already has some peaks that are kissing 0 dB full scale. These white lines at the top and the bottom are 0 dB full scale. And so if I just push the fader up on this sound, these peaks are going to start going over 0, and that's going to result in clipping on my master bus, or printing in the clipping when I bounce a track to audio. And that clipping is going to be completely uncontrolled by any kind of process that's making the clipping sound better somehow. It's just going to be raw samples chopped off, boom, done. And it's not necessarily going to sound good, and I'm not going to be able to understand the sound of it, the actual sound of it, because inside of a DAW on any given track, you're running at 32-bit float. And when you push a peak above the ceiling, that track isn't actually clipping. It's not clipping at 32-bit float because there's tons of headroom above 0 when you're running at 32-bit float. And so if you want to hear what this thing is going to sound like at the end when you print a master or bounce a track to audio, you have to force the clipping on it in a way that you can hear. You have to actually truly clip those peaks at 0. You can't let them slide above 0 at 32 dB float because it's not hearing them clipped. You're not hearing them clipped that way. And so in my method, I say use a hard clipper to shave those things off like a laser beam without changing anything about the signal below the threshold at 0. So that's why my clippers are always set with a threshold at 0, a ceiling at 0, and all I do is drive things harder in and out of 0. I push the peaks up into 0, or I pull them down out of 0. And that lets me actually hear what the signal is going to sound like when I start clipping it to fit it, to move this RMS higher so that I'm making it louder in my mix, right? Okay, so if I start driving this up above 0, you're going to see the RMS get wider. You're going to see this part of the waveform get thicker and fatter and move out towards the outer edges, right? So as I push this up, see how the RMS is increasing? And see how the transients are changing their shape because those original peaks have got pushed up above 0. And yet they're getting shaved off hard by, at this point, we're not oversampling, so they're just literally being shaved off at the threshold value of 0 dB. Right here, hard at 0, completely lopped off. If I push it even harder, the effect is much more drastic. And of course, at this amount, we're going to hear that clipping and it's not going to sound good. We're distorting and changing all those original transients, and it's not good. So the trick is finding that sweet spot where you've pushed the RMS up, but you're not noticing the clipping, or if you are noticing the clipping, you actually think it sounds pleasant. And we can see that some of these transients, like at this amount of clipping, let's put it back to 5 exactly. At this amount of clipping, we can see that some of these drum transients aren't quite as sharp as before, okay? And so this transient area where the transient snap of this sound might exist is now a little bit flattened out and a little bit pushed up against here, and it's all constant, and it's going to start sounding obviously softened and distorted to our ears. Maybe there's a point where you're not going to hear it, and there's a point where you start hearing it. But at the same time, what's happening right at this individual segment of clipping is that fold back distortion that I was showing you on a sine wave. And that fold back distortion, that intermodulation sound, that aliasing sound, sounds like a little spit or crackle of kind of high mid and high frequency noise. And that spit actually kind of sounds similar to the original sharp transient in a different way, psychoacoustically to our brains. And in fact, even though we're watching the transient itself get softened, to our ears and our brain, it might sound punchier. It might sound brighter. It might sound a little more aggressive because we're blending the intermodulation distortion with the original sound that's already very high intensity. And it's just the character of the transient changes in a way that is not objectionable if you find the right balance point. In fact, it can help it cut through the mix more. And I'm going to point you over to someone like Dave Nazi over at Mixbus TV, who's probably the only other producer or engineer I've seen talk about clipping in this way, and has remarked that the sound of clipping can often improve the perceived punch of drum sounds in particular. And this can also be true of a lot of aggressive mid-bass sounds that feature sharp transients and very bright coloration. And just so sometimes, even if you clip those peaks to a point where you can see in an oscilloscope that they're being softened visibly, sometimes it still sounds better. Sometimes it still sounds the same, but slightly different, but not in an unpleasant way. And so, this intermodulation can sometimes be a desirable thing in the context of transparently clipping, or at least clipping in a way that psychoacoustically sounds the same, if not better. And this is a detail I haven't really dived into much in the Clip to Zero method. I just want people to do it and hear it and find that point where it sounds essentially the same or even slightly punchier. And that's where they're supposed to stop their clipping. And so it's effectively very transparent. But the other thing to point out is that any place where the clipping is happening, especially on these really short transients that have also been pushed up above zero, they still look very short. They're still very sharp. And the total amount of time that clipping event is happening is so ephemerally quick. Like if I hold down control and measure this span of the clip, this is 3.19 milliseconds long, these two peaks that are getting clipped. Now, you are not going to hear or perceive any kind of intermodulation distortion that's only 3 milliseconds long, especially when it's separated in time by quite a bit from the next such distortion event. Okay? Your brain won't even hear these. It won't even register these. It's way too fast. I mean, way too spread out and sparse, and the event itself is so short. It's very different than taking a tonal instrument like a vocal that's singing a slow-moving melody. And clipping a vocal is going to sound really bad because you're going to hear the clipping really quickly, and it's not going to be pleasant because it's drawn out and lasts for a long time, like I showed you in that sine wave. But for a lot of material, and not just drums, but other instruments like sharp, plucky, melodic arps and aggressive mid-bass sounds that go, and have a lot of grit and dirt to them. If you clip those transients, you can clip them often by quite a lot and not notice the clipping at all. It's super transparent. okay? Despite the fact that what's happening under the covers is that folded back aliasing I showed you on the sine wave. Despite that. Now that's without using any oversampling at all, okay? Now what I want to show you, this is a typical signal. We're clipping it by 5 dB and we're not oversampling it, but now I'm going to oversample it. And when I oversample it, I'm going to turn off the ceiling, which takes away some of the benefits of oversampling. We're going to oversample this by 8 times. And now watch how some of these transients change. Now they're looking more like the original transient. They have a lot more sharpness and downward slope to them, but there's a big problem. They're going over 0. See that? They're way overshooting the 0 line. In fact, if you look up here at this max peak value, some of those transients are going as high as 1.67 dB over 0. That's by turning on oversampling. Now, why is that happening? Well, it all has to do with this anti-aliasing filter that's hiding up at Nyquist based on your original project rate. And again, go watch that Dan Worrell video to understand some of the geeky science here and what this filter is all about. But the bottom line is, I hope most of you know this. I think some of you may not yet know this. Anytime you put a high pass or low pass filter anywhere in your spectrum, this one's sitting way up at 22, 20 kilohertz. Is probably where the filter point is, or just slightly below 20, but it's super high in the spectrum, and yet it's causing these peaks to go way over the ceiling, or well, rather the threshold of the clipper. The threshold's 0, but the clipping isn't actually clipping at 0 anymore. It's going over 0. It's overshooting the threshold. Anytime you put a pass filter anywhere in the spectrum, low pass or high pass, it has this effect on your signal. It always increases peaks louder than they were before. It's just the way pass filters work. I'm not going to try and explain why. You can dig around if you want to understand why that's true. Just know that it is true. So the minute we turn on oversampling, we have a problem because we're no longer actually truly controlling the peak at the level we need to control it to. This is now going over 0, and I can't hear the clipping anymore, because it's in a 32-bit float track, and it's not truly clipping unless and until I bounce this to audio or print a master. So when I'm working in real time in my DAW, I can't hear what the actual oversampled clipping sounds like anymore. I won't hear it until I finally bounce or print. The point is, I want to hear this clipped now. If I'm going to decide to try oversampling on a sound that I'm trying to control and increase the RMS of and fit it into a small dynamic range so that it fits into a loud mix, I need to hear what this clipping sounds like. And the only way to do that is to turn on some sort of absolute ceiling that will in fact emulate or show you that final clipped sound. Just like that. I turn on the ceiling and now all these things are finally clipped back where they're supposed to be. And so you can see this is what the real transient is going to look like. It's not going to look like this nice skinny slender transient from oversampling anymore. See this nice shape to this kick or whatever that's going on here? If I turn on the ceiling to truly stop it cold at 0, it's now going to become a fatter, longer, more obviously squashed transient. And it's going to have a different sound. And as I showed you earlier with the sine wave, the minute you turn on this ceiling, all these aliasing reflections come back, right? The whole reason you turned on oversampling was it gets rid of aliasing. Except no, when you finally run it through some downstream clipper or limiter that finally pulls all this back down into a tight dynamic range, at least some of that aliasing is coming back because of this process. And so now I'm going to segue a little bit over to pointing out another video by Dave Nazi. He did this about 6 months ago. He's going to tell you in this video kind of the same thing I'm about to say, which is in practice, even though theoretically oversampling is better, theoretically, when it comes to limiting and limiters and mastering limiters, often oversampling doesn't sound as good to most of us, to many of us. Your brain says, theoretically, I should turn on oversampling over here in something like FabFilter Pro, right? It's got this oversampling setting. Everyone tells me oversampling is good. I'm doing a nonlinear process. I'm limiting and crushing this mix down by X amount of, gain reduction. And I should use oversampling, right? Because that will sound better. But a lot of mastering engineers like Dave Nazi will say straight up to your face, nope, oversampling often doesn't sound the way I want it to in a mastering limiter. Okay? I'll put a link to this specific video so you can go hear him say it for yourself. It's a short 4-minute video, right? So it's not just Baffy saying this, it's other people that you can trust. Dave Nazi's really pro engineer. I watch all this stuff. I learn a lot from Dave Nazi. So just like oversampling doesn't always sound good in a limiter, there's a reason. And it's because of the way I showed you in the sine wave that the minute I turned on any kind of hard ceiling, aliasing reflection came back. Now it was reduced compared to not oversampling. It was lower in the spectrum analyzer than it was if there wasn't any oversampling at all. But there's still a kind of foldback. There's still a kind of intermodulation happening. And it still affects the shape of the transients a little bit, right? Now, look at 8x oversampling in the clipper with the ceiling on. Look at the shape of some of these transients. Now let me turn oversampling off and watch how it redraws the waveform. I'm still clipping, but some of these signals are ever so slightly rechanging, ever so slightly modifying the shape of their transients again. This transient looks a little different than when it's oversampled, right? This transient, I want you to watch this transient and this transient. I'm going to turn oversampling back on and watch. It needs to kind of redraw itself completely because it's a 4-bar loop. All right. There's a slight difference here. There's new kinds of intermodulation happening that's different than before. It had one type of intermodulation and aliasing foldback at no oversampling. It has a slightly different type when it's oversampled with a ceiling on. And there's a different audible sound to that. And, as Dave will say in this video, as I say now, I will always test oversampling when I use my final limiter, when I used to push things harder into a limiter, and often I did not like the sound of the oversampling. I preferred the sound with no oversampling in my final limiting. And the same can be true of clipping, okay? So this brings me back to an assertion I pointed out earlier. When you're using a clipper for transparent dynamic range control, as soon as you add the ceiling, it's going to undo most of the benefits of the oversampling, and it's going to sound different. And my advice is maybe as you get down to your final stages of mixdown and mastering, you can check some of the sounds and buses, the tracks and buses that you're clipping fairly heavily. You can try turning on oversampling for those buses. You're going to have to leave the ceiling on, okay? But you can see what it sounds like with oversampling on and off combined with that secondary clipper that's actually enforcing a hard ceiling. And you can just listen for yourself and decide at that time, do I prefer the sound of oversampling this particular set of clippers on these tracks and this bus? Does it sound cleaner? Does it sound better subjectively to me? Do I hear no fundamental difference at all? Well, if you don't hear any difference, why put the extra load on your system? Okay? If you can hear a difference and you like the difference, then yeah, keep the oversampling on, bounce all those tracks to audio, right? Flatten them to audio. So then you only have to worry about one oversampled clipper still active on the bus, right? And then you can move on to the next set of tracks and the next bus. And so in final mixdown and mastering, you can test whether or not an oversampled clipper might sound better. Okay? Chances are most of the time you're not going to hear a difference at all, and therefore it's not worth putting the extra load on your system. And the reason you don't hear that difference is because all of those clipping events and the amount of aliasing that's added is incredibly short duration and spaced out. And so your brain just doesn't even hear it. Your ears don't even hear it. So why put the extra load on your system if it's not a benefit, if it's not a clear, tangible benefit to your brain and your ears? Okay. And then the next point I'm going to make that I didn't write down here is you might choose at that point, if you're in final mixdown and mastering, I actually recommend in a upcoming episode in my Clip to Zero series, I'm going to be talking about maybe you should consider replacing the clipper with something else. Like I always tell you to start out with KClip because it's the easiest to use for workflow. And even if you do turn on oversampling, I haven't got to this part yet, so I've never really talked much about the oversampling of KClip. But if you do try oversampling in KClip, as I showed you earlier, it clearly is adding less aliasing than other clippers might do. But even for KClip, I say, look, you can try oversampling in KClip, but you might actually get even better results by simply replacing KClip with a different saturator that works in a very different way called Newfangled Saturate, or by replacing it with a limiter, a super lightweight limiter called Track Limit by DMG Audio. I haven't got to this point yet in my series. There will be an episode on this soon, so I'm not going to belabor this point here. I'm just pointing out that oversampling the clipper isn't usually the best improvement over a non-oversampled clipper on any given track and bus. Instead, by the time you're in final mixdown and mastering and you're running a huge buffer size on your audio card and you've flattened a lot of tracks to audio, and now you're just in the mode of squeezing every last bit of clean juice out of your project as you can, well, then you can experiment. But up until that point, just use these lightweight, dirty limiters. Use KClip. It's perfectly fine because any small improvement you might hear from replacing this with a much more resource-intensive clipper like Newfangled Saturate or a more resource-intensive limiter like Track Limit by DMG Audio, any benefit you might get from those sounds, it's too early in your project to waste all those resources. When you're first composing and arranging and you're using big resource-hungry synthesizers and you're testing out all these sound design choices and decisions and you're setting up your arrangement and you're recording clips, new MIDI clips and new audio clips, you don't want a lot of latency and resource usage by using limiters and resource-hungry clippers on your project. You want your clippers to be super lightweight so you can hear roughly what clipping a sound is going to be like. You can hear the consequences of your decisions without overloading your project. That's why I say use KClip. Start with KClip on every track, every bus in my Clip to Zero method. Hear the consequences of your clipping. Know what the sound is going to be like by the time this gets to a finished master, okay? You're going to be in the right ballpark. You're going to know the consequences of every decision you make. And it's going to help you make better decisions. And then at the end, as you're in final mixdown and mastering, then and only then, when you have the headroom and the ability in terms of your project CPU load, experimenting with heavier, different replacements for the clipper that control the dynamic range in a slightly different way than just a basic hard clipper, okay? Again, I'll cover that in an upcoming episode in my Clip to Zero series. That's coming up soon. You know, we're already 16 episodes in. Probably around episode 18 or 19 is when I'll start talking about when and if you should replace KClip with something else or test oversampling in KClip. Okay, so have I made all the points I want to make? Yeah, let me go over this a little bit more. So again, in the clip to zero method, I say before you clip from the top, try to squeeze as much crest factor improvement as you can out of any given track. Any new sound you bring into your project, first try saturating it, try coloring it, try giving it some audible heat and maybe a little edge of distortion or saturation or a lot of distortion, right? Sound design, do your sound design first. Don't just throw a clipper on and crunch it to get the crest factor higher. First, saturate it. That's going to make it a little bit perceptibly louder. It's going to reduce the peaks. It's going to effectively make the crest factor smaller in most cases. And so you can probably maybe get that track loud enough to fit into your mix without clipping it at all. Maybe. You won't know unless you do this first. So do your sound design first. And if it's still not quite loud enough, that's when you clip. All right, so here's our original drum track, right? And I'm not even thinking about clipping yet. I'm just sound designing. I'm just going to make these drums sound a little tastier and fatter. So I'm going to turn on Saturn and watch what happens to the RMS versus the peaks. And I'm going to leave the oversampling on in Saturn, so this HQ button is enabled. Turn on Saturn, and you can see that what's actually happening is those peaks are coming down. And that means we could push with the output level, we could push this whole thing up another, X amount of dB before those peaks start kissing zero again. Like it looks like that particular, default warm tape soft saturation. Let me get to roughly another 2.3 dB of loudness. So I push this track up. It's like pushing the fader up by 2.3 dB, but I'm still keeping the peaks under zero, right? Now, if I were to turn off the high quality knob so that it's now not oversampled, you're going to see those peaks come down a little bit. And what that means is I could push it up even louder into my mix. Like, let's say with the high quality oversampling engaged, I still couldn't get this sound loud enough. But by turning off the oversampling, my trade-off is I can get the sound a whole 2 decibels louder to fit it into my potentially already very loud and dense mix that I'm trying to find a new sound to put into, right? So there's always trade-offs. Mixing, producing, gain staging is very much the art of trade-offs, especially if you're trying to work in super loud genres. And so you might say to yourself, well, if I turn on the oversampling, I can only push it 2 dB higher. But if I turn off the oversampling, I can push it 4 dB higher. And if I can get it loud enough to fit my mix with oversampling on and only 2 dB of extra, improvement in my perceived loudness of this track, if that gets me where it needs to get to, great. By all means, leave the oversampling on because theoretically it's cleaner sounding. There's no aliasing in it because this doesn't have a ceiling. It doesn't work that way, right? So that would be the better result. So bottom line, where you can and where it makes sense to do it, by all means, use oversampling when your goal is sound design. Okay, and if that sound design will get you loud enough to also meet your goal of transparent dynamic range control so that you can get this sound loud enough in the mix transparently. I haven't even touched a clipper yet, and maybe just this saturation alone, even with the high quality knob engaged, gets me where I need to be. Great, stop there. Don't even bother with clipping. Clipping's not even an issue in this instant. Your clipper, if it's sitting there on the track, will just be neutral and not doing anything. Okay? But if oversampling makes the higher peaks from that anti-aliasing filter and you still can't get the sound loud enough, then it's worth turning off the oversampling and seeing what it sounds like as you raise it up into your mix where you need it to be. And you can just ask yourself, all right, can I really hear a difference between the oversampled and not oversampled version? Do I even hear that aliasing distortion to begin with? Because again, even Dan Worrell is going to make the case for this. Theoretically, Getting rid of aliasing, good. Practically, most of the time you can't hear it anyway. If this is a super loud, crispy, heavy, hot drum loop, you're not going to hear the aliasing. Almost certainly not. You're not going to hear it. The difference between high quality on and off, you probably won't even hear. If you do, then by all means use it if it'll let you still get your sound loud enough to fit into the mix. But you see, this is where working in a tight dynamic range and intentionally and manually clipping your sounds is, in my opinion, a superior way to work compared to the old school traditional way of working way down at a super low RMS level with tons of headroom above the highest peaks in your signal, and then being surprised by things like this at the very end when you go, wait, that sounded so good, but now that I'm finally running it through my final mastering chain and trying to get this thing up to -8 LUFS or -9 LUFS or -7 LUFS or 6 LUFS or whatever loudness target you have, suddenly you start hearing all the clipping for the first time. And that's bad because you're usually really disappointed and you go, holy crap, my mix sounds terrible when I try to make it loud. But if you're working already up in that dynamic range, distributing all your clips across many different tracks and buses in your project, little tiny paper cut clips, and hearing every result, every consequence of every sound design choice you make, even when it comes to turning on oversampling or not, right, on a saturator. Hearing the consequences of that helps you make better decisions and helps you come up with a final mix that is actually withstanding the process of living in a small dynamic range at the end much better than if you work without thinking about your peaks and your crest factor and the consequences of even something as simple as turning on oversampled saturation or not, right? Hear those consequences every step of the way, helps you make better decisions, and that's pretty much my take on oversampling. Yes, do it when it makes sense to do it. Do it when it buys you something audible and important, and it doesn't impede your goal of getting a sound loud enough. But if it is, turn it off, and like Dan Worrell says, don't stress about it. It's really a subtle difference. We often, new producers especially, will just go ham on things like, should I use linear phase EQ or not? Should I use a high pass filter or not in the low end? Should I turn on oversampling or not? And we'll get into these big theoretical wars, and you'll read, you'll dive through the debates on the forum threads and the Reddit threads and the Discords, and you'll hear different people on YouTube say different things about it, me included, Dave Nazi included, Dan Worrell included. And it's just really confusing. You can overthink it. I don't subscribe to the there are no rules. I'm very much in the camp that there are rules, but the rules are just guidelines. And if you're going to break them, there's sometimes good reasons to break those theoretical rules, like I've talked about in this video. But it all boils down to understanding the rules and why you're breaking those rules. Why? What does it buy you to break those rules? Is the trade-off worth it? And that's my take on it. So I hope this video has been useful. I hope it's helped you understand oversampling a bit better. And I hope it's helped you to understand my take on KClip versus other clippers. And I'll see you in the next video.